बच्चों, आज मैं आपके सामने आपको बताने जा रहा हूं समथिंग अबाउट undamped and damped oscillations. First of all, what are undamped oscillations? देखिए बच्चे, let me take an example of simple pendulum which is oscillating in vacuum. ये वैक्यूम में है, कोई एयर नहीं है, कोई विस्कस ड्रैग नहीं है. इसको तो पुश कीजिए, इट स्टार्ट वाइब्रेटिंग विद टू एक्सट्रीम पोजीशन 1 and 2. ये फर्स्ट एक्सट्रीम पोजीशन, दिस इज सेकंड एक्सट्रीम पोजीशन, and it start vibrating between these extreme positions. Its amplitude will not die with the passage of time. Why? Because the pendulum is vibrating in vacuum. There is no friction force which will oppose the motion. Okay? So it has a constant amplitude throughout its motion. Listen. This is a amplitude, this is time, this is a constant amplitude से ये वाइब्रेट करेगी. Also because amplitude constant and energy of the pendulum depend upon the amplitude, so energy is constant. It means there are no dissipating forces, hence its energy will not decrease, it will remain same. Okay, this is undamped oscillations. Next is damped oscillations. Damped oscillations. बेटे, damped oscillation of one whose amplitude decreases with time and at some time become constant. It becomes zero. I'm sorry, it becomes zero. Constant, it becomes zero. The amplitude, this is amplitude. Amplitude decreases with the time and after some time it becomes zero. Let me realize this motion in actual practice. The rigid sport, this is a pendulum again. I take the example of pendulum. Now, the pendulum is made to oscillate in air. So there is a friction force in air, but depend upon the velocity. So the vibrations will die out very soon, and the pendulum will come to rest in equilibrium. In this case, the amplitude dies out with the passage of time after it becomes zero. This is the damped oscillations. Now, next is what are free oscillations? Free oscillations. Let me take an example of pendulum, simple pendulum. I just give it a push and then I leave it to vibrate. Start vibrating about the extreme, with two extreme positions from the mean position. It is vibrating with the natural frequency pendulum, which is T is equal to 2 pi under the root L upon G and 1 upon nu, 1 upon T is equal to nu is equal to 1 upon 2 pi under the root G upon L. It starts vibrating with the natural frequency. Okay, but in this case again, if there are dissipative forces like air, what will happen? The amplitude dies and after some time it comes to mean position, it will come to rest. Now, to make it vibrate constantly, we apply certain external force which has a frequency nu. to make it vibrate continuously, I subject this pendulum to a periodic force F whose frequency is nu. Its natural frequency is nu naught. When the periodic force was not there, जब हमने इस पे periodic force apply कर दी, after some time the pendulum started vibrating with the frequency of the periodic force. Now it won't vibrate with the natural frequency putra, but vibrate with the frequency of the periodic force. This force oscillations. When you apply a force to some frequency nu at the natural frequency of the pendulum, then it's called force oscillation. Force oscillations. Okay. Now, for example, एक बच्चा है sitting on the swing. ये स्विंग रेस्ट पे है. एक बच्चा इसके पीछे से पुश करेगा and he pushes it after a regular interval of time. So what happens? They start vibrating with some frequency of the force applied by this person who is pushing him. So this is an example of force oscillations. Next example of all oscillation का, free oscillation का, हमारे पास गिटार होता है बेटा. जैसे गिटार, तो this is a string. You just plug this string. The string starts vibrating. This is the free oscillations, free vibration of the string. But when you set the string into vibrations, the air inside the sound box and the guitar body itself, they also start vibrating. The air inside the sound box, guitar box, start vibrating with the large frequency, and hence the sound gets amplified. This is an example of force oscillations. Next is resonance. Let me explain the force oscillation with the help of the equation. Suppose this is a pendulum who has a natural frequency nu naught frequency nu naught. इस पे एक periodic force अप्लाई करते हैं. F is equal to F naught sine of 2 pi t. Sine of 2 pi t. Sine of nu 2 pi nu t. Nu is the frequency of the force. 2 pi nu t. ऑप्शन में क्या होगा बच्चा? ये इसकी नेचुरल फ्रीक्वेंसी है. वाइब्रेट विद नेचुरल फ्रीक्वेंसीज. जब हमने ये periodic force अप्लाई की, क्या होगा? The pendulum starts vibrating with the frequency of the force, periodic force. It acquires the frequency of the periodic force. Start vibrating with the frequency of the periodic force, not with the natural frequency. These are four oscillations. Now, what is F naught? F naught is maximum force. मान लीजिए ये बॉब इसका मास m है, यह ऑसिलेटिंग सिस्टम इसका मास m है, सस्पेंडेड बाय इनएक्सटेंसिबल वेटेड स्ट्रिंग, द पेंडुलम मास का m है. नाउ जब फोर्स अप्लाई करेंगे, द डिस्प्लेसमेंट ऑफ द पेंडुलम बिकम y is equal to f naught divided by 4 pi square m nu naught square minus nu square into sine of 2 pi nu t. So what you see, the displacement at any time given by the F naught maximum force 4 pi square m is the mass of the pendulum, nu naught the natural frequency of the pendulum, and nu is the frequency of the periodic force. So the displacement at any time depend upon the frequency of the periodic force. This is the displacement of the pendulum, and periodic force is applied. the pendulum start vibrating with the frequency nu of the pendulum force. Now, what is resonance? What is resonance? Resonance क्या होता है? देखो बच्चे, अगर periodic force की frequency is equal to natural frequency of the pendulum, what will happen? Then it is vibrating with the frequency nu naught, natural frequency. B applied external force with frequency same as the pendulum. When the matching is there, the amplitude of the pendulum increases infinitely. Theoretically, it never happened at all, but theoretically, the amplitude increases by infinite amount. See here, when mu naught is equal to mu, when mu naught is equal to mu, y is equal to infinity. The amplitude increases by infinity, which never happens. It means the energy of the pendulum becomes infinite. It never happens because there are dissipative forces. These dissipative forces limits the value of the amplitude. So what happens when the periodic force की frequency और जो oscillating systems की frequency मैच कर जाती है, तो इसकी amplitude बहुत large हो जाता है in axial particular purpose large हो जाता है. This is resonance. Let me give an example of the resonance. See, ये वाइन ग्लास है, शेप ऐसी है. तो जो वाइन ग्लास की जो नेचुरल फ्रीक्वेंसी होती है ना, नेचुरल फ्रीक्वेंसी न्यू नॉट, इट डिपेंड्स अपॉन द शेप ऑफ द ग्लास एंड आल्सो कंपोजिशन का बना होता है मतलब कंपोजिशन एंड द शेप. अब यहां पे कोई सिंगर है, वो उस नोट पे सिंग कर रहा है, सिंगिंग विद दैट नोट जो कि मैच कर, जो जिसकी फ्रीक्वेंसी न्यू नोट है, द नेचुरल फ्रीक्वेंसी ऑफ द ग्लास. Singer is singing with the note new note, the frequency new note, जो कि इसकी अच्छी फ्रीक्वेंसी है. जब ये फ्रीक्वेंसी मैच करेंगी आपस में, तो इसकी एनर्जी ट्रांसफर होगी ग्लास को. This transfer is there, and the glass start vibrating with natural frequency, and it will break. It happened with there in actual practice. Let me take the example microwave oven. The microwave oven. Microwave oven. Now, इसमें क्या होता है बच्चा, अगर कोई हम ऐसी वेजिटेबल रखते हैं जिसमें पानी होता है, बच्चे सुनो बच्चे, अगर फैट या पानी ना हो ना उसमें वेजिटेबल में, तो माइक्रोवेव काम नहीं करता है. Microwave only works if the vegetable contain water content. In fact, अब ये माइक्रोवेव है, it is emitting radiation of frequency nu and lambda. ये रेडिएशन होता है ना, ये जो आपका जो अंदर माइक्रोवेव ओवन में जो वैसे रखी है. अब इसके जो वाटर मॉलिक्यूल होता है ना, उससे भी नेचुरल फ्रीक्वेंसी होती है. हाँ, तो जब रेडिएशन एमिट होती है माइक्रोवेव में, उसकी फ्रीक्वेंसी इसकी नेचुरल के मैच की जाती है, तो वाटर मॉलिक्यूल स्टार्ट वाइब्रेटिंग vigorously with large amplitude. Hence, the food gets cooked, become hot. This is the principle of the microwave oven. Next is guitar. Again, I take the guitar. ये गिटार है, इसको प्लग किया, स्ट्रिंग्स आर वाइब्रेटिंग विद सर्टेन फ्रीक्वेंसी. इसके अंदर एयर होती है, बॉक्स तो गिटार जिसमें ये इफेक्ट्स होती है, उसमें एयर होती है, बॉक्स इटसेल्फ. ये जो फ्रीक्वेंसी, जो एयर की नेचुरल फ्रीक्वेंसी है ना, ये जो उसकी फ्रीक्वेंसी उससे मैच की जाती है, फ्रीक्वेंसी ऑफ द स्ट्रिंग, तो जो आपकी एयर कॉलम होता है स्टार्ट वाइब्रेटिंग विगरसली. इससे क्या होता है, साउंड ऑफ द हैंड्स अकर एंड साउंड ऑफ द string instrument guitar amplified. So this is all about the chapter after the chapter.